Right, well, we'll resume now, assuming that we've got contact with Miss Grange. Hello.
Yes, hi. Hello, Mr. Chairman. Can you hear me?
We can, and you can hear and see us, I hope.
Yes, I can. Thank
Good.
you.
In that case, we'll ask Mr. Hanson to come back in. Would you ask Mr. Hanson to come in, please? Right, Mr. Hanson, all ready to carry on?
Absolutely.
Good, thank you very much. Yes, Miss Grange, when you're ready then.
Yes, thank you. Yes, can I just say at the outset of this afternoon's session, Mr. Hanson, that can you try hard to stick to the answer to the question that I pose this afternoon? Just because I know you're trying to be very helpful, but we are going to run out of time and not finish your evidence today if you keep on adding additional answers. So can you try really hard to concentrate on the question I've asked you and to answer as succinctly as you can? That would be great. Thank you.
Yeah, okay.
So can we go to JSW 704 at page 3? JSW 704 at page 3. So this is an email from Mr. David Bradbury of JS Wright to Mr. Mahoney of PSB on the 11th of June 2015. And he says this, he says, Hugh, Paul Hanson from Building Control has just called. Can we let him know ASAP if we mean the statement highlighted in yellow? Or can it be deleted and resubmitted? He wants us to basically delete it as it doesn't tie in with what we have discussed with him. If we can respond quickly, we can avoid him rejecting the TS. I think that's technical submission. Thanks. And then what he's done is extracted part of PSB's technical proposal, technical submission below that from paragraph 1.1.2. And we can see that there is a sentence which is highlighted, which reads, I think it's meant to read, it should be noted that as the system is designed to extract air from the lobby via the open stairwell door, the system is not designed to comply with all the requirements of the aforementioned code of practice. And that aforementioned code of practice we can see is the code of practice BSEN 12101 part 6, the specification for pressure differential systems. And in the paragraph, because in the paragraph before that, it said that the velocity that's been chosen of 2 meters per second is in accordance with the recommendation for a Class B pressure differential system as defined in that code of practice, yes?
Yeah.
Now, can you recall telephoning Mr. Bradbury, as this email indicates, and asking him to delete that part of the technical submission?
The conversation was asking a question, actually. Do you want me to relate briefly?
Well, just answer my question first. Did you ask him to take out that part of the technical submission, to delete those words there?
Because the difficulty I've got here is that there's 2 things mentioned, you see, and
I see. So what did you ask?
The simple answer. Sorry.
What did you ask to be? Did you ask for something to be deleted from the submission?
I suppose yes. Basically, that the result of the conversation was that it should be deleted. Yeah, because there's an.
And what was it that you wanted deleted? Was it that sentence that we can see there that's highlighted?
Yeah. So, yeah. Do you want me to explain the reason why, or yes or no answer? Right. So, what he's actually saying is that air is going to be extracted from the lobby via the stairway.
Yes.
Via the open stairway, which would imply that you're taking smoke from the lobby into the stairway. Now that is completely that's not what we're looking for. So I rung him up to say, do you really mean what you say? Because if you are, that system will not work. And he didn't mean that at all. It was a miswording or whatever. So I said, well, then you shouldn't say that because that's not what you're doing. And I reconfirmed with him what the proposal was, to extract from the lobby, and the stair door being used as inlet air from the stair. And I think that was the way it was worded was badly worded, basically, to try and describe that.
So you didn't read that it's designed to extract air from the lobby via the open stairwell door, as suggesting that the stairwell door was providing the inlet air. You read it as the air would be extracted through the stairwell door and up, yes?
Yeah, because it says via the open stairway door. Per via means by way of, so it's stating that you're extracting smoke from the lobby by way of the open stairway door, and that's, you don't want smoke in the staircase, basically, if you're extracting that way, but that wasn't their intention at all. It was just, it was worded not correctly, I would say. So hence the reason you wouldn't want to put this in the strategy, because it's just wrong.
Yes, I follow that, but did you also ask for the second part of that sentence to be removed as well, where it says the system is not designed to comply with all the requirements of the aforementioned code of practice?
We certainly had a discussion about that, because the problem with making a statement like that is that there are certain elements of that British standard that are referred to in the SCA guide, so it then becomes vague what you're talking about.
So I think your answer to my question is yes. Is this right, that you did ask for the words, the system is not designed to comply with all the requirements of the aforementioned code of practice?
Yes, basically.
To be deleted?
Yes, because it was misleading, basically. Yeah.
Why did you think that was misleading if, in fact, the system wasn't going to comply with all those requirements in that code of practice?
See, the thing is, it's a confused sentence.
Did you think that the system was supposed to be designed to comply with the requirements of that code of practice?
Yeah. No, it doesn't, because so there are certain elements of that code of practice that is being used in this system. Clearly it doesn't comply with the whole standard, but to mention it is too vague to say that it won't comply with the. So which part of it doesn't it comply? You don't really want to say that in the specification, because it could be anything it doesn't comply with. The critical requirements it couldn't comply with. So it's just the wrong way of wording it, basically.
But by taking it out entirely, the reader isn't left with a clear impression that it's not been designed to comply with all of those requirements. The reader is left with what you see in the paragraph above, which might suggest to some people that it has been designed in accordance with a Class B pressure differential system. Do you see that?
If I just clearly read the paragraph. I mean, the above paragraph is pretty good at describing what they're doing, actually, because it clearly states that it's a mechanical extract system, and as we've previously established, 12101 is actually a pressure differential system. So you're clearly stating you're using a mechanical system, and then it clearly states that in this instance you're using the value of the 2 meters a second, designed in accordance with a Class B pressure differential system across the staircase. So I felt that paragraph captured very well, and to then add you're not fully complying with it is pretty obvious. This is about industry understanding. If you're saying it's a mechanical extract system, it is not a depressurization system, it's not a pressure differential system, so that's very clear. The focus here is taking the value of the 2 meters a second as a performance criteria that you're going to prove on site, and that was quite important. I didn't want to detract away from that by the vagueness of the paragraph, the wrongness of the first part of it and the vagueness of the second part of that sentence.
Well, you say it's obvious that it wasn't a pressure differential system, but what I'm suggesting to you is that because there's reference to that pressure differential system standard, that code of practice, that if it wasn't going to comply with all of those requirements in that code of practice, wasn't it very important, not just for you and PSB at this time, but for all future readers of this technical submission, to understand clearly that it was not going to meet all the requirements of that code of practice? Wasn't that very important?
I mean, if you wanted to say something like that, you probably needed to word it differently.
But why didn't you suggest alternative wording rather than simply deleting it?
Remember, I'm building control, so it's not for me to get involved in how the design specification is written. I was pointing out the misleading sentences.
I see, but you've just suggested that part of it is deleted. Isn't that getting involved in the submission?
Yeah, I think we're crossing. But if you're describing the system is extracting smoke through the stair, you've got to not say that, because that's not what the system is doing. So
yes, I follow that. I follow that, Mr. Hanson. But I'm talking about the second part of that sentence, which you have accepted. You asked to be deleted because you thought it was unclear. And what I'm suggesting to you is that in doing that, you are getting involved. And if in fact it needed to be alternative wording that made clear that not all of that standard was complied with, why didn't you do that instead?
Just to repeat your question, is it, are you saying, why didn't I suggest alternative text to restate what they intended to state? Is that what you're...
Yes, that's what I'm suggesting, is that if you thought it was unclear, but the statement nevertheless needed to be made, why didn't you just suggest alternative
ultimately, it's the designer to write the specification. What I was ringing about is that the two sentences were misleading and unclear. So it's not as though I give an instruction to the designer to delete, they need to look at what they're writing and decide whether they need to write it in a different way. So I'm not giving an instruction, I can't give instructions, I'm highlighting that if this was sent to us as a submission, which it was, then I can't approve it with it, the wrongness and the vagueness, basically.
I see. Well, let's move on. Can we look at now at what Mr. Mahoney has said in his statement? He's the designer of the system. I want to go to his first statement first. This is PSB 401329 at page 5. And I want to look at paragraphs 24 and 25. So he says this: the design I developed was for a depressurization system. In other words, a system which achieves smoke control using depressurization principles achieved by mechanical extraction. Depressurization systems are one of the most common types of smoke control system used in buildings in the UK. They are designed to deliver protection to the protected space, in this case the stairwell, by extracting air and combustion products from the common lobby to create a pressure differential and opposing airflows between the stairwell and the common lobby. Now, just pausing there, was that your understanding of how the system was designed?
Right. Well, this again, we've got a terminology issue here, because it is not a depressurization system. So if we...
just pausing there, you say it's not a depressurization system. Do you accept that by having mechanical extraction through the lobby vents, north and south shafts, you would by definition be depressurizing the lobby? Do you accept that?
You are, but because the industry has a specific definition for depressurization in 12101 part 6, use of that term would mislead the reader to believe that it is one of those systems. So it's all about terminology. But what it is, it's an extract system. You almost don't need to say depressurization.
But even to answer my question, did you understand that the consequence of it being a mechanical extract system was that it would depressurize the lobby. Did you understand that at the time?
The term depressurization isn't something that entered my mind, because the way these systems work is that's not the objective. The objective is to do something else.
What is the objective as far as you understand it?
Is to remove smoke from the lobby to avoid smoke entering the staircase.
I see. And then he says in paragraph 25, the system at Grenfell Tower was designed so that when smoke was detected in a common lobby, causing the system to function in smoke control mode, extract fans would operate to extract air and combustion products from the affected common lobby via the shafts. This would reduce the air pressure in the lobby and therefore create a pressure differential between the lobby and the stairwell, while the door between them remained closed, preventing smoke from migrating into the stairwell. Now, is that consistent with how you understood the system was going to work?
Again, we're using terminology. The idea of the staircase being kept clear of smoke by airflow being pulled effectively from the stairway is, in fact, how the stairway isn't affected. And by pure coincidence, both the pressurization principle around the staircase door and the SVA extract system have the same principles.
Right, I see.
If you see
Let's
what I
look
mean.
at what he says. Let's look at what he says in his second statement now. If we can go to PSB 401373 at page 8. And I want to look at paragraphs 40 and 41. So he says, he's given us some explanation before. He said, it follows, I did not design a pressure differential system which are designed to comply with all the requirements of BS EN 12101 Part 6. And then he says at 41, my design reflected a more common type of mechanical extract depressurization system, a performance-based building appropriate solution widely adopted as a type of smoke control system, and which were often referred to within the industry as depressurization systems, and is commonly called the Colt shaft mechanical shaft system. Do you see that there?
I do, yeah.
Now, in terms of paragraph 41, did you understand that this was going to be a performance-based building appropriate solution?
Yes.
And did you understand it to be a system that was often referred to within the industry as a depressurization system?
I was aware that the term depressurization is misused in the industry.
And were you aware that it was commonly called the Colt shaft mechanical shaft system?
Yeah, we're aware of the Colt shaft system is actually not, it's not a residential system actually. I didn't regard that as relating that to residential systems, to be honest with you. So probably the answer is no, I suppose.
No. Did anyone say to you at the time when you were receiving these proposals that the system was commonly called the Colt shaft mechanical shaft system?
No, I don't remember that at all.
Now, the technical submission that PSB prepared, we'll go to revision 3 of it in a moment, that you approved. Can we agree that it doesn't make clear that PSB are adopting a performance-based building solution? We saw the key paragraphs from that just a moment ago.
Oh, I see. Right, yeah, right. You're not going to show me anything else.
No, I'll tell you what, let's look at revision 3. So this is PSB 50209. This is the 12th, this was issued on, we can see from the revision history in the table, it was issued on the 12th of June 2015.
Yeah,
And it says, sorry, can I continue?
Yeah,
it says paragraph removed from 1.1.2. That was the paragraph that we were just looking at. And this is revision 3. We'll see an email in a moment where we can see that you approved this submission and said it was satisfactory. But if we just go to page 3, and we look at 1.1.2, where we get the smoke control proposals, we can see there that the first paragraph is as per the extract we were just looking at, the final smoke control system designed to provide the existing stairwell with protection from the ingress of smoke from a fire within a dwelling by means of a mechanical extract system. System has been designed to provide an averaged open door velocity across an open lobby stairwell door of 2 meters per second. This velocity is in accordance with the recommendation for a Class B pressure and for pressure differential system, as in that code of practice BS 12101 part 6, specification for pressure differential systems. And then the next paragraph, which said it didn't comply with all of that code, has been deleted. And it goes on and says the smoke control measures will be implemented in 2 phases. Phase 1 to reinstate the natural system, and then it goes on at the bottom, the PLC control system will have links to the new fire alarm system to provide initiating signal. Once the signal is received, all the dampers in the smoke affected lobby will open and all dampers on other floors are to remain closed. And then if we go over the page, we can see that it's talking about what the components of it will be. There'll be an HMI, human mechanical interface panel, there'll be override switches, etc. So that's what we see in this technical specification about the design basis. So just to ask you the question again, this does not make clear, does it, that PSB are proposing a performance-based building-specific solution?
I think
it doesn't say that, does it?
It doesn't use those words, but that is what the 2 meters a second paragraph is describing.
I see. That's what that conveyed to you, did it?
It does, yeah.
It does not make clear that it was or it equated to the Colt shaft system. That's not stated anywhere, is it?
I'm not quite sure how the Colt system's relevant.
No. And it doesn't make clear that it did not comply with all of the requirements of BSEN 12101 Part 6 because that had been deleted, yes?
Yes, because it is not a pressurisation, depressurisation system. If we're looking for where the performance criteria is, it's the paragraph that states the velocity past the door, which is a test of the building.
Yeah, so let's go back to that. I think what you're trying to say is that the performance criteria for this system is in that first paragraph. If we go one page back to the bottom of page 3, you're saying that the performance criteria was that single criteria, yes? Providing an average open door velocity across the lobby stairwell door of 2 meters per second, yes?
Yes.
That's the performance criteria, is it?
That's the performance criteria, yeah.
And that, I see.
That's what they would need to meet on site in order for the system to achieve the objective of stopping smoke affecting the staircase.
And just that, yes?
Yes.
Nothing else?
When you say, it depends on the context of your question. This is a test that's carried out that shows that the objective is achieved. So providing the 2 meters a second criteria is regarded as suitable and appropriate, i.e. we can rely on it, then if the system achieves that objective, then it achieves the objective of keeping the staircase clear of smoke.
I see. And you say it's a test that's carried out that shows that the objective is achieved. Was that the only objective of this system, to keep the stairs free from smoke?
I'm not quite sure where. Are you leading to...
You talked about that being a performance objective to keep the stair free from smoke. And I'm asking you, was that the only performance objective you were aware of for this system?
There was a consideration of the lobbies relating to a prescriptive natural system, in that, you consider how much smoke ends up being in a natural system compared with a mechanical system.
When you say there was When you say that there was this is important, Mr. Hanson, when you say there was a consideration of the lobbies relating to a prescriptive natural system, in that, you consider how much smoke ends up being in a natural system compared with a mechanical system, where do we see that anywhere in the technical submissions that you looked at and approved?
Yeah, I don't think it is stated.
No. So there's no consideration of what the conditions in the lobbies would be, is there?
Well, apart from the performance of the system.
Well, you've said the performance objective of the system was to keep the stair clear. Where do we see the performance objectives for the lobby?
Well, it's not directly mentioned.
No. Now, if we go on to JSW 401747, we can see this should be an email dated the 24th of June 2015, in which you confirm that the proposals are satisfactory. So we can see you say, "Hi Dave," to Mr. Bradbury of JS Wright. "Please find attached my comments regarding the smoke control system for the stairway lobbies, the proposals for which are satisfactory." So you appear to be there confirming that in revision 3 of the technical submission that we were just looking at, the proposal was satisfactory. Is that correct?
That's correct, yeah.
And in the accompanying memorandum, which we can see at page 2 of this document, we can see that you also say, just before the numbered paragraphs halfway down, the proposals outlined in technical submission revision 3, that's the one we just looked at, are satisfactory. And then you make 3 points. And in the final point, you say at point 3, you say, generally the components of the system should conform to the guidance on smoke control to common escape routes. And that's the SCA guidance 2012, yes?
That's correct, yeah.
So you're saying that the components of the system should comply with that guidance, yes?
Yeah.
Did you ever record any additional reasons as to why the proposal was approved? In essence, this is all we can see in the documents about your reasoning as to why you were content with this proposal. Do you remember ever recording anything else in writing?
No.
Now, just for completeness, if we look at CST 401230, we can see a further memorandum from you to Mr. Hoban dated the 26th of January 2016, in which you've approved revision 3 subject to some comments. And if we look at the 3 short points which appear at the top of page 3 on the smoke control system, we can see it's exactly the same 3 comments we were just looking at. Do you see that there? So again, the same comments repeated in the final one about the components of the system complying with the SCA guidance. Now, you tell us in your witness statement that you approved this submission regarding the smoke control system, which you say you agreed was acceptable, subject to these 3 comments. When you say it was acceptable, do you mean that you considered that the proposed smoke control system was compliant with parts B1 and B5 of the building regulations functional requirements?
Is this because of my heading B1 only? Is that the reason you're...
Well, I want to understand whether you considered that this system did comply with parts B1 and B5 of
Yes.
the building regulations. Yes. Now, I'm going to come back in a moment to ask you some more detailed questions about the design of the system, but just moving forward with the chronology of what occurred on the project for the moment. If we look at paragraph 62 of your first statement at page 11, you tell us in this paragraph that you attended a working demonstration of the system. You say, although commissioning certification had been issued, I knew from past experience visiting other sites that there can be problems with inlet air functioning properly. I suggested to John Hoban, the area surveyor, that we attend a working demonstration of the system. Alan White from JS Wright, the smoke control system installers, also attended to demonstrate the system on the 4th of May 2016. Now, can you help us? What exactly did that demonstration involve?
It was a sequence operation. So basically it was showing that everything happened in the right sequence. So therefore, set a detector off in the lobby. Does it activate the power ventilation system on the floor that the signal was generated? Are the dampers on the other floors kept closed? Any necessary inlet air, in this case it was permanent, would operate, but as it was permanent it didn't need to operate.
I see. And did you actually go to multiple floors in the building and look at whether the dampers were open or closed in accordance with how the system should be operating?
Yeah.
How many floors did you look at? Can you recall?
Off the top of my head, I can't. It was a few. It was just a random few. Do you want me to explain the background? I know you don't want me to go on, but do you want me to explain the background about why I did this test?
Briefly.
Right.
Yes.
So we didn't have a mechanical ventilation engineer who had been made redundant. So we were relying on the commissioning report. This was the first job we'd ever done without a mechanical ventilation engineer, and I felt uncomfortable walking away from the job without seeing that the system worked in its basic function. So there wasn't the intention here to repeat the commissioning, which I already had. So the simple test is making sure everything works in the order it's meant to work, and that was the intention of that test. And it really was going outside of management guidance, because with the loss of the BREG engineer, we weren't expected to go down and witness commissioning or any kind of inspection, but I just felt myself that I should, to be comfortable to see it working. So I suggested it to the area surveyor.
Were any measurements taken on this occasion?
No measurements, no. It was purely a sequence testing, basically.
Yeah. Did you at this stage or at any other point confirm or witness the physical path of the air movement away from the stair?
No. Well,
why not?
You say the air path away from the stair. I mean, when you're in the lobby, you can feel the extract blowing. Are you referring to the smoke test that Beryl Menzies suggests?
Well, I'm coming to that,
okay.
yes. I want to know whether there was any attempt to confirm the physical path of air movement away from the stair during this test. And it sounds like there wasn't, because it was just a sequence test. Is that right?
Yeah, absolutely. I mean, with an extract system, in that building you had two shafts with an air path extractor for both shafts. So it's pretty obvious that the air path is going to be away from the staircase. There wasn't an issue with maybe one of the extract points was near the staircase. There could be a problem with the flow going in the wrong direction. There wasn't a reason to, and it isn't common practice to do such a test anyway.
Did you confirm that there was no significant inflow from other leakage paths, such as from the fire flat?
It was a sequence. Yeah, so to understand this, it's a sequence.
Sorry, yes or no? Did you confirm that there was no significant inflow from other leakage paths, such as the fire flat?
For a sequence test, you wouldn't need to do that. So I didn't. You know, it's not needed for what I was doing. I was doing a simple.
Did you speak? Yeah, okay, I understand that.
Okay.
Did you speak with the commissioning engineer at any stage?
Yes, the commissioning engineer.
Yes, Mr. Grenville Partlow of PSB. Did you actually speak to him?
No, I didn't. No. And the chap who come down and showed the or carried out the sequence testing, if he was a different person from memory, I can't recall. But I spoke to that chap, but not necessarily, unless it was the same person, if you know what I'm saying.
Did you actually see the operation of the dampers during that test? Did you actually see them operate to move?
Yeah, we did, yeah.
Were you shown any aspect of the HMI, human mechanical interface panel, in the lobby that operates the system?
I mean, I was not doing a BREG, what we would call a mechanical electrical engineer check at all. So I wouldn't have, that's not the purpose of that simple check.
Yeah. Can we look at clause 9 of the SCA guidance at this point? This is RBK 402932 at page 56. This is the 2015 SCA guide. So this is under the heading Commissioning and Acceptance Testing, and in the second paragraph it says, as smoke control systems are primarily life safety systems and or for assistance to the fire and rescue service, it is imperative that the smoke control system is tested by the installer and then offered for witness testing to the authority having jurisdiction to prove its compliance with the project specification and the approved design criteria. Do you see that there?
I do, yeah.
And were you aware of that part of the SCA guide when you did your visit on the 4th of May 2016?
The question misses a particular important element in that normal practice would have been for the mechanical and electrical engineer employed by building control to go down and carry out that function. So what happened is, as building control department had made the mechanical and electrical engineer redundant, that function was no longer possible. So the management arrangement was that we accept the commission certificate without going down there and witnessing the test. So to go back to your question, I chose to go down there to satisfy myself that everything worked in sequence, but not to witness what's described in that paragraph.
Yes, I see. So I think what you're saying is because you didn't have a mechanical and electrical engineer, this part of the SCI guidance wasn't followed. Is that correct?
Yes.
Yes.
Yes, you're correct, yeah. Because no one actually went down there. I was doing something different to this, basically, my simple witnessing of the sequence.
Yes. So if we were to look at the detailed list of checks that have to be carried out under this guidance for either a pressure differential system or a mechanical extract system, those tests were not carried out in your presence, were they?
You're correct, they weren't, no.
Were you aware that carrying out a cold smoke test is important in any system where there is extended travel distances?
I'm not aware of that. I mean, it can be a useful guide if there are concerns about particular circumstances in the job, but the cold smoke test isn't, as far as I'm aware, a standard procedure. But it's a tool that can be used where, I have used it on some jobs where there is some concern, but it isn't a standard thing that you do.
Well, if we look at Ms. Menzies' report at BMER 607, page 7, paragraph 31, she says, paragraph 31, in my experience, systems installations that have not been subject to modelling are generally demonstrated on site using a cold smoke test to illustrate the directional flow of smoke, the speed of dispersal and level of visibility. And then she said, whilst this will not fully, and if we go over the page, replicate an actual fire situation, it will be indicative. As far as I can ascertain, this was not undertaken, suggested. So she's saying in her experience, this kind of cold smoke testing is carried out, but you're saying that's not your experience, is that right?
Yeah, I agree, yeah.
Do you agree that using a cold smoke machine can help evaluate the system's efficiency and identify any dead spots in the system in terms of ventilation?
It can do, but it's a very incomplete type of test. Because
But wouldn't that have been appropriate at Grenfell Tower, given first the extended travel distances in the lobbies?
I'm not quite sure how to phrase the answer to that. So what you're really saying is that there's a belief that the extract system might not have performed adequately compared to what we expect in a prescriptive natural vent system.
No, that's not quite what I'm saying. Can we look at a diagram? This might help me put these points to you. If we go to a diagram at BLAS 5037, page 25, this is from Dr. Lane's phase 1 supplemental report, and there's a figure there, 15.5b. So if we can zoom in on the figure that she's included there. Here we can see the arrangement of the lobbies from levels 3 to 23 of Grenfell Tower. We can see the flats around the outside, and we can see Dr. Lane's travel distances are marked in blue and blue lines. Do you see those?
Yeah.
And you can see that to go from flat 4 in the middle on the left, she's measured a 10.3 metre travel distance. Do you see that?
Yeah.
Now, in fairness to you, the BRE report following their survey at the tower, for the transcript, that's MET 3039807, page 24, paragraph 32. They measured 9.3 metres, not 10.3. But whether it's 9.3 or 10.3, that was an extended travel distance, wasn't it, compared with the 7.5 maximum in ADB, yes?
Yeah, it was, and it was an existing situation, yeah.
Yes, but Mr. Hanson, did you actually ever think about that extended travel distance at Grenfell Tower? Were you aware of it? Did you have it in mind when you approved the proposals for the smoke control system?
I mean, I was aware there were distances in the building that wouldn't follow the guidance of today, definitely, yeah.
You were aware. Did you ever measure the distance yourself so you knew exactly what the travel distances were?
Yeah, I did, yeah.
You did. Did you ever record that in a document?
We're talking about the distances. Which level are we speaking about?
Well, this is all levels 3 to 23. Could we have the diagram back up, perhaps? This is the lobby arrangement for all of those levels. Did you ever get a tape measure out and actually measure the travel distances?
I wouldn't say I did on the upper floors. The lower floor was really replicating the same sort of layout. So you had distances in that order.
Right. Did you ever ask anybody what the travel distance was for the upper floors between levels 3 and 23 of the tower?
I didn't, no.
Did you note the geometrical configuration of this lobby? We can see that it's an I shape. So you've got a kind of narrow corridor down the middle where you've got the stair door and the lifts, and then you've got corridors off that. So it's like an I. Do you see that?
I mean, what's significant about this layout is that you have the ventilation at either end of the corridor.
Well, you have it at either end of the middle of the corridor. It's not exactly down the ends, is it? It's down the middle. It's at the top and the bottom.
Exactly, yeah. If you were to compare that to a natural system, where you have 7.5 metre corridors, the vent can be positioned, and in fact it's encouraged to be positioned near the staircase. So you do end up with, in the prescriptive case, with corridors that effectively you will get some smoke logging at the end. And this is just how systems of, how the design of smoke control systems have, or not smoke control systems, natural systems have evolved.
Yes, I understand that, but I'm really interested, and I wanted to try and focus your answers on what you appreciated at the time you were signing off on this smoke control system and saying it was acceptable. did you think about the layout of these lobbies, including the eye configuration, and in particular whether that might mean there could be dead ends or dead
Yeah,
spots?
I did. Yeah, absolutely. Yeah. Because it's obvious.
You did think about that?
It's obvious, yeah.
And did you ever write down any assessment of why you thought, despite that, it was still acceptable?
I didn't write it down, no. It's not really the normal process to analyse every single thought process. That's all I can say.
But where you've got an extended travel distance, Mr. Hanson, shouldn't there be a clear record of why the system is nevertheless satisfactory in terms of conditions in the lobby?
Now you say it, perhaps added information would have been helpful.
Yes, if we go to an email, JSW 402945, and we look at an email, second email down from the top, from you to Mr. Hughes at Ryden, copy to Mr. White at JS Wright. You say, hi David, the figures you've sent do not appear to be extract readings, they should be in meters per cube per second. The readings you've sent are velocity readings. We'll come back to that in a moment. And then you say, after that, remember that the testing of the powered vent system we are witnessing tomorrow should be in accordance with section 9 and item, and then there's no item specified, of the attached SCA guide. Do you see that there?
Yeah.
And by this stage, were you working from the 2015 SCA guide? Can you help us on that?
No. The way the date of documents works is that it's the date of the application of the proposal, which was 2014. So we wouldn't have been able to say you should then use a guide that come out after the date of application. It's a general principle in building control. I think Beryl Menzies mentions this.
Yes, I see. We'll come back to a couple of specific parts of that SCA guide in a moment when I'm asking you some more detailed questions about the design of the system. But just finishing off now with what happened in terms of the actual process during the project. If we go to PSB 50214, this is the final version of the PSB technical submission, which was revision 6, dated the 15th of March 2016. We can see that in the revision history table. And if we go to the bottom of page 3, the description of the system remains identical to the description we had before. So there was no change in terms of the basic description of the system. There was no change. And we can see, if we go to RBK 403778, that this revision 6 was sent to you by Mr. Hughes of Ryden on the 3rd of May 2016, ahead of the demonstration that you then witnessed on the 4th of May. So technical submission, we know that was revision 6. You can see that in the subject heading. Do you remember ever considering and reading carefully that version of the technical submission?
Yeah, I did, yeah. It was basically accompanying the commissioning report. So it was kind of supporting the commissioning report. But I did note that there were some changes that, there were changes in there that weren't really significant to the...
Right. If we go to PSB 50224, this is the commissioning report you were just referring to, dated the 28th of April 2016. This is the PSB above ground commissioning report. We can see at page 7 it's signed by Mr. Partlow and Mr. White for JS Wright. We can see that at the bottom. And it appears to have been accepted by building control because we know that a completion certificate for the entire works was then subsequently issued. Now, what I want to ask you is that after this report was produced, so this report we can see has been signed off in April 2016, building control then recommended changes to the system on the 2nd of June 2016. we can see the letter requesting the changes to the system at RBK, if we can bring this up, RBK 3013224. It's dated the 2nd of June 2016. And if we can look at point 5 of this letter, it's sent to Ryden. It says this: various openable windows within the main entrance lobby to Grenfell Tower area required to be linked to the main powered ventilation system for the building, so that such windows open on operation of the system and provide make-up air at the bottom shaft for the system. So that's what's being requested by building control, is it's an adjustment to the bottom of the smoke control system, or the configuration of it, so that there's more make-up air at the bottom shaft. Now,
do you want me to clarify what that means? Because you mentioned the term shaft. So
sorry, I apologise, that may have been inaccurate. It says bottom shaft for the system, provide make-up air at the bottom shaft for the system. I think that's why I said that. But do you want to just clarify exactly what was being requested by building control?
Okay, so after our witnessing of what I call the sequence testing, detector, damper opens, inlet air opens or is available. When we got down to the ground floor, there was a lobby there that, as existing, didn't have any ventilation at all. So just a little bit of background to this. Generally speaking, if I see something that could be improved in the building, I mention it to the design team. So I think it was the architect at the time when we went around the building early on. I noted there was no ventilation to this lobby on the ground floor, and I think it was to a piece of plant. So I suggested, well, part of the process of the work you're doing on the building, you could take your ventilation shafts down to serve this lobby, and then you would have a ventilated lobby at that point. So this isn't something we couldn't ask for under the building regs, but it was an improvement. So anyway, they did do that. So when we went down and witnessed the sequence testing, I noted there was no inlet air path from the stairway to this ground floor lobby, because the configuration of the stairway was such there was a door and screen between the normal stair inlet path.
I see.
So
okay,
therefore,
thank you.
So what we're really saying then is that in order for the lobby...
I think...
Do you understand?
Sorry, I think we understand. But the point I'm getting at is this. Well, first of all, perhaps you can confirm who was it within building control that was responsible for considering the commissioning report and then issuing the final building control completion certificate. We see that certificate at MAX 402655.
Right, okay. So
who was it, first of all, that considered the system's commissioning report and thought that was acceptable?
Yeah, so I looked at the commissioning report within the limitations of not having a BREG engineer to support me on that. Then I informed the area surveyor that that's acceptable under our new scheme, and then the area surveyor would then have, did you say the completion certificate?
Yes, who then issued the final completion certificate?
Yeah, so
if we look at that, it's MAX, can we bring it up? MAX 402655. It's signed by John Allen, we can see at the bottom.
Yeah, so the completion certificate is issued by the area surveyor. The John Allen signature is basically a department signature that goes on all the letters.
So who was responsible for, in fact, issuing this certificate, if not John Allen? Was it Mr. Hoban?
Yes, you're correct, yeah.
Right. So does it amount to this? You approved the commissioning report, but Mr. Allen issued the final building control completion certificate. Sorry, Mr. Hoban, the final building control completion certificate.
Yes, the latter of what you said, yeah.
Yeah. So, but back to this point about changes being asked for in the system, the commissioning report is dated April 2016. You asked for changes to be made to the system at the lower levels on the 2nd of June 2016. Why wasn't there a commissioning report requested for the final system?
Right, I see, right, okay. So take the AOV that was added to the staircase on the ground level. There's two angles to this. The airflow values that were produced for the commissioning showed that the lobby did in fact achieve the 2 metres a second at that level. I think it was more than 2.9 or something. So what I was actually saying is, despite that, you've actually got no inlet air path to the staircase to sustain that. So what we were saying is, if you add the AOV, it would sustain the inlet air path.
So you thought it would make it better, so you didn't insist on a further commissioning certificate, is that correct?
Exactly, yeah. So there seemed to be little point, there's another reason as well actually, there seemed little point in getting to recommission the whole system, because it would not have made it worse, it would have made it better. But the second point is, remember that, as I mentioned just now, this lobby at ground level is not something we could have asked for the system to be extended down to serve, because it was existing, so they were adding to the system. So that basically was the reason, yeah.
Were you notified that the necessary Regulation 38 fire safety information had been passed to the responsible person about the smoke control system?
I mean, it's not my role to deal with Regulation 38.
I see. So you never thought about Regulation 38?
I wouldn't have thought about it, because it's not in my consultancy role, the consultancy role doesn't involve giving advice on Regulation 38.
Yes, I see. And just back to the commissioning certificate, just one point of clarification. What does that commissioning certificate actually demonstrate? Can we agree in particular that it wouldn't cover, for example, the fire resistance of the dampers to maintain compartmentation?
Absolutely, yeah, it wouldn't cover that at all, no. Basically, the commissioning is showing that the system operates as it's meant to do, but it's not a qualification of equipment or construction standards at all.
Yes, I understand. Now, I'm going to ask you some more questions now, more detailed questions about the final design of the smoke control system, and what aspects of the system you actually thought about and checked prior to approving that system as satisfactory. Now, we've seen that the technical submission that you approved states that the system was to provide the existing stairwell with smoke protection from fire in a dwelling. Now, just to be absolutely clear, did you understand that the sole function of this system was to protect the stairs from smoke entering from fire in a flat?
I'm just trying to equate the question. So you're talking about a performance standard for the door, but was there anything else you're saying?
Yes. Was there any performance standards for anything other than the door to the stairs?
That was the only performance standard for the door to the stair.
I see. If we can look at the SCA guidance now, so we know that your evidence is that the system should have been designed in accordance with this guidance, and we've seen emails where you sent this SCA guidance to professionals on the project. If we can look at the 2015 version at RBK 402932, and I want to look at page 6, clause 2.1. So this is under a section at the beginning of this guidance that's called primary objectives. And we can see in the second paragraph, it says, where the travel distances are no more than 7.5 metres in distance from the door to the staircase or sterile lobby to the most remote apartment entrance door, so at Grenfell Tower, that would be to the flat 4, the primary objective of smoke control in residential buildings is to protect the staircase enclosure by ensuring that the stairway remain relatively free from smoke and heat in the event of a fire within a dwelling. Do you see that?
Yes.
And then if we go 2 paragraphs down from that, we can see it says, however, where corridors are extended, the primary objective of the smoke control system is to protect both the common corridor and the staircase enclosure. there are considered to be two forms of extended corridors. And there's extended, typically no more than 15 metres, and then significantly extended, which have more than 15 metres travel distance. Now, were you aware of this part of the 2015 FCA guidance when you worked on the Grenfell Tower project?
Yes, I was, yeah.
And I've asked you what you were aware of in terms of travel distance before, and we've looked at the layout of the lobbies in Grenfell Tower, and we've seen that they are somewhere between 9.3 and 10.3 metres is the longest distance to the stairs from the furthest flat. Do you accept, looking at this guidance, that as the travel distance was more than 7.5 metres, it was not permissible to treat protection of the stair as the primary objective, and instead the primary objective should have been protection of both the common corridor, in this case the lobby, and the staircase?
Effectively, it should take consideration of both cases.
Yes.
If that's the, yeah.
Yes, if we're following this part of the FCA guide, yes?
Yeah.
And can we agree that nowhere within the design documentation or nowhere within any of your notes do we see any consideration of the objective of protecting the common corridor as distinct from the staircase?
Not in documentation, no. I mean,
was that something that you actually thought about at the time you were approving the Grenfell Tower system?
Basically, it is what we regard as a qualitative decision, not based on any kind of modelling or anything in that nature. What you had is a building that was existing, that had an existing, very old smoke control system, and the objective was to replace it with a system reasonably, bearing in mind the limitations of the size of the shafts, etc., to provide a system that at least achieved what the building did have, and actually in some cases improved it. So it's a point that will make it quite clear is that where you have a natural system, so the natural 1.5 ventilator to the lobby, you get a lot of smoke in the lobby, basically. And therefore, there's no requirement for tenable conditions. This is just as the case exists. And generally speaking, smoke would spread from the lobby into the staircase as well. So here, we're actually having a system that has effectively a better level of protection to the staircase because we're using the objective of the 2 metres a second to stop smoke affecting the staircase, where in a natural system it would affect the stair. In relation to the means of escape, you have existing corridors, and your positioning of your ventilation at the end of those corridors will be significant compared to a natural system where maybe the ventilator is located elsewhere. So it's really a case of when you have an existing building, to actually apply new standards though it's a new building becomes unreasonable. So that was really the decision.
I see, but
it's difficult to the thing is, it's difficult to quantify something like this because you're looking for a quantifying element to it, basically.
I'm not just looking for that, Mr. Hanson. I'm looking to understand why we don't see anything like what you've just said set out in any of the design documentation to explain what the thought process was about protecting the stair and protecting the lobby.
Yeah, maybe it's a criticism that it should have.
If we look at, for a moment, clause something in BS 9991 2011. This is at BSI 50621, page 11, clause 0.2.3. If we look, so under 0.2.3, this is smoke control in common parts. I want to look right at the end of that section in the last 5 lines. We can see it says, where smoke control is used to provide compensation for extended travel distances, it is the responsibility of the designers to demonstrate that the ventilation system can provide tenable conditions for the occupants using the route with extended travel distances. Do you see that there?
I do, yeah.
Were you aware of that part of that British standard when you were approving the system?
I was aware of it, but it doesn't apply to the cases that you're speaking about. I can explain if you wish me to elaborate.
Well, can you explain why we don't see any consideration in the design documentation about the need to maintain tenable conditions in the extended travel distance lobby? Why is that not even considered and addressed?
Because the criteria that's used in the SCA guide is you need to achieve tenable conditions for long extended corridors. So corridors between 15 and 30 metres. That's your criteria then for tenable conditions.
Well, that's not what this is saying, is it? It's saying where smoke control is used to provide compensation for extended travel distances. It doesn't talk about particular extended travel distances. It's the responsibility of the designers to demonstrate that the ventilation system can provide tenable conditions.
Yeah, the only guide
I'm going to ask the question again. Why do we not see any consideration in the design documentation about maintaining tenable conditions in the lobby?
Because it isn't the practice of the industry to achieve tenable conditions in corridors unless they're really extended between 15 and 30 metres.
Mr. Hanson, I'm sorry, Ms. Granger, I'm just going to come in. You said a moment ago that you didn't think this applied to the case we're considering. Did I understand?
In the context of the question, because what the question that's been put to me is that the suggestion is these corridors should have had tenable conditions, and that should have been part of the design. So we've only looked, you're shaking your head, we've only looked at tenable conditions in long extended corridors between 15 and 30 metres, and there is a direct requirement for those corridors to have tenable conditions.
Right, but I think the passage we were looking at, can we have it back on the screen, do you think, please? Which Miss Grange put to you.
Yeah.
You said at one point, and you started an answer by saying this doesn't apply, and then you went off to deal with some other point. Yes, it's page 152, line.
Yeah, I'm talking about the case
7.
where
You said I was aware of that passage, but it doesn't apply to the cases that you're speaking about. And I just wanted to make sure why you said that, because you didn't actually give an explanation.
Okay, right, okay. So let's give that explanation. So longer corridors, it throws a bit of history here.
Try not to get into too much history.
Yeah, it does help though, because otherwise you don't. The context is important.
All right,
basically.
go on.
So we've had existing system. The old standards included a ventilated lobby that was regarded at the time as being suitable, not tenable conditions at all. Mm-hmm. This is just what we had. We've now started seeing the need that the designers extending corridors quite substantially. So the decision was made is where you're going for a substantial extended corridors, 15 to 30 metres, you're now looking at, we've got to have a new criteria. Bear in mind these codes were written years and years ago. We just had a natural vent. Now we're saying actually, if you're going to extend the corridors this long, we need to have a definite standard for tenable conditions. So that's what we do with these extended corridors. You've got a situation here that is an older job that was designed under the guidance at the time was natural vent. They went for an experimental mechanical system, I call it, and achieved a certain level of acceptance they felt was acceptable at the time.
Can I just ask you to think about this? In paragraph 0.2.3, and Ms. Grange read this sentence to you, it says where smoke control is used to provide compensation for extended travel distances. Are you saying that expression, extended travel distances, only applies to corridors of 15 metres or longer?
Yes, it does. Yeah.
Right. Well,
what I'm really saying in the context of...
Just wanted to understand that's why you say it doesn't apply to this case.
Yeah. So the criteria, the tenability criteria that we would apply to a long... If that's clear, then...
I think I understand why you say this didn't apply, It may be that Miss Grange would like to follow that up, though, because there is no reference, at least in that sentence, to 15 metres or longer. Right, Miss Grange, I'm sorry, I've broken into your line of questioning.
Yeah. No, it's fine. Perhaps if I can move on to, stay with the same theme about tenability criteria, if we can look at the SCA guide again, RBK 402932, page 15. There's a whole section of this guide called Tenability Criteria for Means of Escape. And there's detailed guidance given about determining performance criteria to be set for maintaining tenability. And there's all different ways in which you can set performance criteria. You can set them according to time-dependent things based on a timeline of physical events. You can set them based on likely but challenging fire conditions in a steady state way. I don't think we need to get into the complexities. My basic question is, why don't we see in any of the design documentation any consideration of tenability in the lobbies and what the performance criteria was? It may have been, the performance criteria may have been something which you would describe as, not very good in the lobbies, but why do we not see any performance criteria which says this is what we are anticipating will be the conditions in the lobbies, and this is why it's acceptable? It might say, well, because the travel distances aren't that great compared to 7.5 metres, there might be all sorts of mitigation that
I understand what you're saying.
Provide. But why don't we see any consideration of performance criteria for tenability, including in the lobbies and indeed in the stairs?
Right, okay. So going back to what I was saying, this tenability criteria for means of escape is about our extended corridors between 15 and 30 metres. This was set up in order to be able to consider these extended corridors as being acceptable. But we're speaking about an existing building that had slightly longer lobbies that would have been acceptable with a natural system that had no tenability criteria. What we've done with this job, effectively, is provided a smoke ventilation system that has ventilation at each end of the corridors, and you're likely to get a better result than a natural system. There's going to smoke log your stair and a layer of smoke in the natural corridor.
Yes, but we don't see any of that, do we?
That's a fair point. That's a fair point.
In the design documentation. Sorry, let me finish. What you've just said, we don't see any of that written down by the designers or by you as building control when accepting the system, do we?
That is a fair point, I suppose. Maybe that there should have been an explanation for that.
Yeah. And if we look at page 16, the page on from this, there should have also been consideration of tenability criteria for firefighting. So what it says in this first paragraph is, while it's acknowledged that it's extremely challenging to design smoke ventilation systems to maintain tenable conditions for occupant means of escape in common corridor and lobby areas, once the door to the flat of fire origin has been opened for fire service intervention, consideration should be given to what additional protection these smoke ventilation systems can offer firefighters during firefighter operations. Do you see that?
I do see that, yeah.
And again, we see no consideration whatsoever, do we, in any of the design documentation about what consideration was being given to the protection that the system would provide to firefighters during firefighting operations when the flat door was open.
Right, okay. So once again, the whole idea of this section in the SCA guide is about the long extended corridors beyond 15 metres. If I can refer you to the third paragraph under 533, this explains that area.
Well, underneath it says, therefore, for common escape routes where smoke ventilation systems are being proposed to justify extended single direction travel distances of more than 7.5 metres in length, well, that's where we are here. Specific assessment of the conditions within these spaces should be completed by the system designer to demonstrate that effective fire service intervention can actually be achieved. So it's not talking about beyond 15 metres, is it? It's talking about more than 7.5 metres, yes?
I can see your point the way it's written.
Okay, that's so.
The point I would make though is that I'm just repeating what I said really, that we had an existing situation there whereby the intention was to provide a new mechanical ventilation system in existing situations. This is basically designed for new buildings.
Yes, I see. Mr. Chairman, that would be a good moment, I think, for the afternoon breaks. I'm about to move to a related but slightly separate topic.
Well, that sounds like it would be a good moment then to have a break.
Yeah.
Well, Mr. Hanson, we'll take the afternoon break now. We'll come back at 3:30, please.
Okay, thank you.
Please don't talk to anyone about your evidence while you're out of the room.
I won't.
Thank you. Ms. Grange, 3:30, please.
Thank you.
Right, we're ready to resume, so I'm just going to ensure that we've got contact with Miss Grange.
Hello, can
Hello.
you hear me?
Hello, Miss Grange. Yes, we can see you, and I think you can see us, can you?
Yes, I can, thank
Good.
you.
Then I'll ask Mr. Hanson to come back in. All right, Mr. Hanson, ready
Yep.
to carry on?
Yeah, thank you.
Well done, thank you very much. Yes, Miss Grange.
Yes, thank you. I now want to look at something in British Standard EN 12101 Part 6. If we go to RBK 45054, and I want to look at page 57. So this is the British Standard, and we know that the 2 metres per second was taken from this British Standard as per the design documentation. But I want to look within section 9.1 at the bottom of this page. There's a section on depressurization within this standard. And it says this, it says the objective of a depressurization system is to achieve the same protection at the doorway between the depressurized space, e.g. a basement, and the protected space, e.g. a stairwell, as would be achieved by pressurizing the protected space. And then it goes on, it is important to note that there is no protection of any part of an escape route within the depressurized space itself, which may be entirely filled with smoke or may even be fully involved in a fire. This constitutes a fundamental difference between depressurization and smoke exhaust ventilation. Do you see that?
Yep.
Now, if we can look at a helpful diagram that Dr. Lane produced in phase 1 at BLAS 5038, page 4. In this diagram that was presented in her phase 1 evidence, what Dr. Lane is attempting to do is explain how this system, the PSB design system, would work at Grenfell Tower. And what we can see, first of all, in the yellow arrows, is that smoke or air is extracted by fans from the lobby at the north and the south shafts. We can see that. So you've got extraction on both sides. And then in the blue, air is being pulled through the open stair door and the lift shafts to the lobby at less than 2 meters per second due to the open flat door. And then lobby extract pulls smoke from the fire flat through the open door. Now, just to be clear, what this is showing is that when you open the door to the fire flat, because the lobby space is the depressurized space, as well as having the effect of protecting the stair or trying to protect the stair, you're pulling smoke from the fire flat into the lobby. Do you see that?
I wouldn't say you're pulling it from the fire flat. I mean, the smoke coming from the fire flat will naturally have momentum along the corridor. What you're actually...
Yes, but in this system where you have depressurized the lobby, you've lowered the pressure in the lobby by extracting air from it. When you open the fire flat door, do you accept that the low air pressure in the lobby would then mean that smoke was drawn out into the lobby?
Not for the reasons you say. So let me just... You showed me in the standard text about a depressurization system, which is a different system. That's where you're extracting from the floor area. And they qualify that by saying that it could be fully involved in a fire. So that's something different. So I wouldn't connect the two together. So looking at the fire flat, when someone opens the flat door, there is the expectation, without any question, that smoke will flow from the flat, out of the flat door, and it will flow out by its own momentum.
Yes, but won't this system increase the propensity of that to happen because the pressure is lower in the lobby?
Well, if I just continue my analysis, as it were. So we've got smoke with its momentum flowing across the corridor. What you're then doing is interrupting the flow of this momentum by your extract system in both locations, extracting away. This question of depressurization, I think it needs to be separated because it is a different system. You're extracting smoke from the fire room. You're extracting here smoke from the lobby. I mean, this is the fundamental principle of this type of system. You're stopping the smoke approaching the stairway, and you're extracting it, but it doesn't. Basically, the fire doesn't need this system to make it flow into the corridor. It will naturally do it.
So are you saying that it will make no difference to the extent of smoke flowing into the lobby, that you've depressurised the lobby by extracting air at both sides?
It should actually make the conditions better because what you're doing, you're interrupting the flow. So when the smoke is flowing across the corridor, you're actually now saying we're sucking it out. The system, you'd have to have a very powerful system to actually cause your normal smoke momentum to be pulled further. You haven't got that powerful a system in this building to do that, I would suggest. This comes from, we look at 3D models for new jobs, and you get a great idea of how smoke flows, and you see this all the time. Smoke flows in the corridor, it flows along the corridor, and then you see the extract system kick in, and it pulls it and stops it affecting the staircase. And when you see it visually, it really paints the picture. So I'm afraid I can't accept that this system would have made the conditions worse by pulling it. It's actually improving it. That's the whole idea of it. And it's the whole concept of the way these systems work.
Just to be clear, when the flat door gets opened, you're saying you don't think this system makes it any worse than when the flat door's closed? Is that what you're saying?
Sorry, just repeat the question.
When the flat door is opened, are you saying that it doesn't make conditions worse compared with when the flat door was closed? Is that what you're saying?
I think you're talking about something different. About the flat door being closed.
I'm trying to focus on what would happen at the point of the flat door being opened.
Smoke will flow out. If you didn't, the best example I think will help is say we didn't have the extract system at all. So we purely had a lobby without any ventilation. What will happen is smoke will flow naturally into the corridor, and
through the closed door?
No, through the open door, because the picture you're painting is the door is open so the person can escape from the flat.
Yeah.
Yeah. So when they open the flat door, smoke will flow into the corridor, and it will do that by its own natural momentum until it finds something else that will interfere with it and allow it to go somewhere else, which is likely to be the stairway. It will flow up the lift shafts. But if we interrupt that flow and say, actually now the momentum of smoke is being interrupted by an extract system here, this will then, you'll still get lots of smoke flowing, but it will start pulling it away, and you'll get better conditions than if you had a non-ventilated lobby.
Can I just interrupt?
Yeah.
I think the point that you're being asked to consider is whether the rate of flow of the smoke from the fire flat into the lobby will be increased by the effect of the fans drawing air out of the lobby.
Yeah, I did pick up on that earlier, and I mean, it probably depends.
What's your?
Well, my general view is that it shouldn't affect it, but
I thought
there's a possibility that if you have a very powerful system, and the system, the extract system is right near a flat door, for example, that it could happen. But you tend to have these very powerful systems on our extended corridor cases that I've explained earlier, because you do need an extract rate quite powerful. But I've not seen, from 3D modelling, I've not seen, and bearing in mind 3D modelling is a version of reality, it's not reality, so we have to bear that in mind. But they're the best tools we've got to look at things sometimes. So from my experience, I wouldn't have thought that smoke would be, not wouldn't have thought, I could almost say that is not the case, that it won't pull the smoke. You'd have to have an extremely high extract rate, and it would have to be closer to the flat door for that to happen, in my view.
I understand. Thank you very much.
Sorry to expand.
Sorry, does that suggest that, did you actually think about this risk at the time you were approving the system? Did you actually think about the risk that it might pull a greater rate of smoke into the lobby when the flap door was opened?
Well, I didn't think about it because it's not a known phenomenon I recognise. And bearing in mind that, I'm not, as building control, I'm following practice in the industry. So what you're almost criticising, to be quite frank, is that the SCA guide is incorrect. Because that's the process I've described is the way that extract system works.
I see. But also, and importantly, wouldn't another consequence of opening the flap door be that the airflow across the stair door would be reduced and the protection to the stair would be reduced? Did you ever consider that?
Absolutely, because that's part of the test. So as we've established on this job, we're taking an on-site test to use as demonstration that the system achieves the objective. So part of that test involves a process whereby you have a certain number of doors open while you're performing this 2 meters a second test. So you've actually taken that into account.
Can you help us then as to why the technical submission that you approved didn't make clear the design scenarios on which its performance criteria were based? For example, it doesn't refer to the 2 meters per second extract rate being appropriate for both means of escape and firefighting phases. Can you help us as to why that's the case?
I think you may need to repeat the question.
So let me approach it a different way. Let's look at the SCA guide, because you keep referring to that, and we'll go back to it now. The 2015 guide, RBK 402932. And I want to look at page 23. Here, in this section of the SCA guide, it tells you what documentation should be included. And we can see in the third paragraph, it says the documentation should include at least the following information. And we can see it says a description of the residential area and the proposed ventilation system, the design criteria and performance objectives of the analysis, the scenarios investigated, details of the techniques used and related information, the results of the analysis, a statement as to whether the design criteria and objectives have been met, and summary input-output data for the modelling that's used. Now, can we agree that there was a total failure to comply with this aspect of the SCA guide because we don't see documentation that tells us at least the majority of those bullets? It doesn't tell us the design criteria, the performance objectives. It doesn't tell us the scenarios that have been investigated. Can we agree that that was the case?
Yeah, this paragraph is about modelling, isn't it? So we're not modelling. The way this system's been considered is taking a value that's tested on site. So you'll see supporting animations, etc., etc. And
I don't think this paragraph is about modelling solely. If you look at the second paragraph, it says the results of the analysis should be documented and may be provided in the form of a report, together with any necessary supporting animations from advanced modelling. And it's telling you what the documentation should at least include. Now, can you help us? You were intimately familiar with the SCA Guide 2015. Why did you not insist that the documentation that was provided met all of these requirements?
I think I related it to computer modelling, basically. Also, you said the 2015 version, and I don't know whether it will add any significant difference, but there is in terms of the modelling, I think.
Well, let's
we
look
are
at
on the-
let's look at the 2012 version, if that's what you're
Yeah.
referring to. If we go to LFB 3059241, at page 14. Where there we see in this earlier version, the 2012 version, there's a section 5.4 documentation. Results should be presented in an appropriate form for each agreed criterion. And then the documentation should include at least the following information: a description of the area, the design criteria and performance objectives, the scenarios investigated, the techniques used, etc. So a very similar list appeared in the 2012 guidance. Did it occur to you at the time to check what documentation ought to be provided for compliance with the SCA guide?
Not in that context, no. I can understand what you're saying, but this really is where you're, in my view, it's where you're modelling a scenario, whereas this is more of a performance-based criteria.
Well, I would suggest to you that the whole thrust of the SCA guide, 2012 and 2015, is that you can come up with an alternative performance-based design, but you have to carefully document and explain what your design criteria are, what your performance objectives are, and what your scenarios are that you've investigated as a minimum. Can we agree on that?
Yeah, I do agree there is a lack of that in description in the approach, whether or not that's referring to it.
But the difficulty is, how would you know that the system could work without those performance criteria being defined, without the objectives being defined, without the scenarios being investigated, and without confirmation that it meets those scenarios? How could you effectively approve the system without that kind of analysis being done of this alternative system?
It's merely more of a qualitative consideration based on the existing building.
Yes, I see.
I don't disagree, though, that you've got a point that this should have been documented better of how the consideration were arrived at. So I acknowledge that, definitely.
Yes, but it's not just a failure of documentation, is it? Because unless you document these things, you can't then assess whether the system is meeting the design criteria and performance objectives you've set, because you don't know what the system is designed to be doing. Do you see?
Yeah.
If we could look at what Dr. Lane has done in her latest report, if we go to BLARP 2, 5035 at page 148. So BLARP 2, 5035 at page 148. So in this table 5.4, and there are a number of tables in this chapter of her report, but this is a summary table where what she's done is she's summarised on the left-hand side the information that the SCA guide requires in that list that we just looked at, and she's explained in the right-hand column whether or not PSB's technical submission covered that or not. And we can see that she said in amber that there wasn't a proper description of the residential area. It doesn't describe the evacuation strategy. It doesn't describe the travel distances, the other active and passive fire protection measures. We can see below that, under performance criteria, that the only performance criteria provided was for the open door velocity, for a maximum pressure difference and the door opening force. And she says those don't cover the range of performance and tenability criteria set out in the SCA guide. Then when it comes to scenarios being investigated, there are no specific scenarios investigated. So it doesn't analyse, what would happen if there was this escape of occupants from the fire flat or other flats on that floor. It doesn't indicate what would happen during the firefighting phase. So no scenarios are investigated, no record of the techniques used to assess the system performance, no comparative or deterministic analysis. So what that means is there's no analysis comparing it with a prescriptive system, and there's no analysis looking at overall performance presented. And there's no statement as to whether the design criteria and objectives have been met. Now, can we agree that was the picture that we now see presented in the design documentation?
Yeah, I mean, we are referring to the 2015 version that really dealt with extended corridors, etc. I don't disagree with you that there should have been a better description of how a better description along the lines of this, but maybe not as far as you would go to consider an extended corridor case where you're specifically looking for tenable conditions.
Yes. In terms of acceptance tests, if we could look at section 12 of BSEN 12101 part 6, this is at RBK 45054 on page 72. So within this British standard, there is guidance on acceptance testing of pressure differential systems or depressurization systems. Were you familiar with this series of acceptance test stages?
No, I wouldn't have been, because it was a matter that would have been covered by our mechanical and electrical engineer.
I see. So what we see is there are a series of different acceptance tests that are recommended for these types of systems, which require you to very carefully record the results of the system. Can we just look at an example of this? So if we go to clause 12.23 on page 73, we can see at the top of that page there's acceptance tests here for air velocity, 12.23. Now, there was an air velocity performance criteria. We know that was 2 meters per second between the lobby and the stair door. Now, if we look on within this testing, what it tells you is that you've got to test across a range of doors. So if you look at 12.2.3.3, the measurement of flow velocity through the relevant doors shall be taken with all other doors open or closed in accordance with the appropriate class of system described in clause 4. The doorway shall be clear of obstructions, and you've got to see figures 2, 3, 4, 5, 6, etc. And if we look at page 30, this tells us what all the other doors that need to be open during the test should be. So at the bottom of the page, we've got the airflow criterion between staircase and lobby. And it says the air supply should be sufficient to maintain that 2 meters per second through the open door between the staircase and the lobby at the fire affected story, with the air release path on the floor still open, and all of the following doors are open between. And then so you've got all the doors between the lobby and the fire affected fire compartment open, the stair and the lobby on the story below the fire story open, the firefighting lift shaft on the lobby on the story below the fire story open, and it goes on.
Yeah.
Now, in summary, would you agree that this testing is done because you need to be sure that the system is powerful enough to maintain pressure if different scenarios occur during the fire event?
Totally agree with you, yeah, you're right.
Yeah. So opening different doors will simulate what might happen in real life, where other occupants escape, or where you enter the firefighting phase, yes?
Yeah, totally agree.
And can we agree that during the firefighting phase, you may have a situation whereby the fire brigade have set up on the lobby below and have trailed their hose through the stair door below, up the stairs, through the stair door, and then through the flat door. So you'd have 3 doors open
Yep.
at that point.
Yeah, absolutely.
So these are the kind of scenarios, when we were talking about scenarios before, that we don't see any analysis of. And in the testing that's done, we don't see any testing that's done with different doors open to check that the system can still cope in those situations, or at least test what the system does in those scenarios. Do you agree?
No, basically. But I can see where you're leading. The technical submittal proposed the 2 metres a second airflow test in accordance with this standard. So my expectation is it will be tested in accordance with this test procedure and opening and closing the relevant doors to the Class B system. So that's clearly stated in the technical submittal.
Yes. Now, pausing there, did you ever check that had been done?
No. Going back to my position with the loss of our breg engineer, when we had a breg engineer, they used to go down there and witness this kind of thing.
Yes.
But
Let's look at the 2 sheets of readings which you were provided with in the above ground commissioning report. This is at PSB 401152. If we could go to page 8 of that document. So we get 2 pages of readings. There was this page, which shows readings in meters per second of the fans at different levels. And then over the page, we can see at each floor level, in the second column along, open door meters per second, we just get 1 reading per floor, 1 open door measurement for the 24 floors. Do you see that?
yeah, I do, yeah.
And in fact, there's no record of actually which door this was, although we could perhaps assume that it was the door to the stair, yes?
Well, it has to, because that's the one you're testing. You're testing the door to the stair.
So there's no record of any testing with other doors open or closed when these measurements were taken, yes?
Well, the expectation is they would test to the standard. I mean, in any kind of commissioning report, I wouldn't expect the testing procedure to be repeated. Bearing in mind here that you didn't show it, but there is actually an illustration. So you'd have to reproduce all the text that you showed about the doors, plus the illustration. And that's not the kind of thing you would expect to be included in the submission report.
So
Bearing in mind this commissioning report was done to comply with the technical submittal.
Yes, I see. So is what you're saying that you assumed that this was some kind of summary, and that you assumed there'd be more data that was taken behind this, which did comply with that acceptance set of criteria?
Right. I think I can see where the important reading, or the reading we're interested in, is the flow rate across the door to the staircase. So that's the reading you would take. The second column is the reading you would take. The other doors being open, you don't take any readings. They're open so that you've got flow coming from other areas. And what you're trying to do is make sure that the 2 meters a second is maintained whilst you've got other leakage paths. But you don't measure those leakage paths because they're not of importance for the value. The value we're interested in is the staircase door value.
But can we agree that if you were doing acceptance testing in accordance with the British standard that's referred to in ADB, you would do those tests with a range of other doors open?
Absolutely, yeah. And that's the expectation, because that's what was proposed.
Yes.
Otherwise, you're not proving the system. Could I just...
Sorry, do you want to say something?
You showed me another section of that guide of the BS. Was I aware? And I said I don't think so. I don't know whether all the tests there are related to a pressurisation system or a depressurisation system. So I'd just like to make that point. I may have answered wrongly because it may not relate to that type of system. That's all.
I see. Okay. Can we look at an email now? So this is about opening door force on the door. This happens to be the fourth acceptance test in BSEN 121016 is the opening door force tests. Now, if you go to an email, this is PSB 401152. So this is an email that Mr. Harrison sends to Mr. Earl of JS Wright, dated the 26th of May. And I want to look at the third paragraph. He says the control system will also has pressure sensors added into each ventilation lobby to control the speed of the fans, to ensure that when the doors on the escape routes are closed, that the opening force on the door does not exceed 100 newtons as detailed in BSEN 12106 Part 6. This was witnessed by your Mr. Alan White, and the reading, which was not recorded in our commissioning sheets, but read as 85 newtons on the scale provided by JS Wright. Now, it follows from that, and it's consistent with the commissioning report, that there is, in fact, no record of what the door opening force was in the commissioning reports. That's right, isn't it?
You're probably correct.
Now, without some readings of door opening forces in the commissioning report, how could you be satisfied that the system met the requirement that the opening force on the door would not exceed 100 newtons, as set out in the British Standard, as identified as a criteria in PSB's technical submission?
Yeah, that they were using this pressure sensor device that it was certainly new to me. I took it, maybe innocently, that the mechanical process or electrical process of them testing it, what they did, they actually put the word yes at the end of this little section. So I took it as that meaning that they carried out the test and the automatic system depressurised the space. They tried the door and it was okay. Now, whether that should have been recorded for each door, I mean, you may have a point.
Shouldn't it at least have been recorded? Sorry, shouldn't it at least have been recorded as a minimum for a representative?
Well, now you say it, I think you've got a fair point. Again, I'm without a breg engineer, so one of the problems I lacked here is that this was a system, an electronic system, and it would have been great to have had my breg engineer look at it and then decide what he felt, or he or she felt was appropriate on the commissioning.
I see.
I do take your point, though. That
you should have had readings of at least representative.
Yeah, I mean, I don't know what the normal process is, but the point you're making, it makes sense. But I looked at it on the basis that they've used this automatic system and they've regarded it as acceptable. But you're right to say they haven't recorded the readings.
Yeah.
So we're relying on. It goes back to the fact that what we, as a borough, when we decided to make our breg engineer redundant, we're relying on the professionalism of the installer, designer, and because I've not been a breg engineer, I'm not used to the expectation of how the commissioning report should be written.
Yeah.
So I did my best in the case.
You keep referring to the phrase breg engineer, B-R-E-G, and
okay, do you want me to explain that? Right, okay. So historically, back in the GLC
briefly, just what does the acronym stand for?
Building Regulation Engineering Group.
I see. And was that back to the M&E engineer not being there?
Yes. We gave them, because they used to be a group in the GLC times, we just kept calling, even though we had one person, we just kept calling them breg, as a colloquialism, if you like.
I see. Can we now go to the topic of dampers and compartmentation associated with the smoke control system? Was anyone at building control responsible for checking on site that important aspects of compartmentation associated with the smoke extract system were complied with?
Right, well, any site checking would have been the role of the area surveyor, and they would have inspected, considered as necessary inspections as they felt necessary during the process.
So are you saying it was Mr. Hoban's responsibility in relation to the smoke control system to check that elements of that system necessary to maintain compartmentation were complied with?
Yes, that's right, because it was a damper. So therefore, any fire door, damper, that kind of thing was the area surveyor's reference. Whereas in the old days where we had the mechanical vent engineer, it wouldn't have been the mechanical vent engineer's reference to do the dampers.
Right.
You know,
So does it
they're on
follow
the
that-
mechanical side, as it were.
Yeah. Does it follow that you didn't give any consideration at all to, for example, the fire rating of the dampers?
In terms of the technical submittal, you mean, which is my role?
Yes, I mean so PSB actually selected Gilbert's Series 54
Yes, I
dampers,
did, yes,
which
yeah,
are
yeah.
mentioned in the technical submission. Was it part of your job to check the fire rating of the dampers that they used?
Yes, it was, yeah. Part of the technical submittal, there are, although I don't deal with the mechanical side, then that side of things, that the basic specification for the dampers would have been my reference, yeah.
And do you recall actually checking the specification for the dampers to make sure that they were appropriate for the
Yes.
use that they were being put
Yes.
to?
Yes.
You did. How did you carry out that check?
Right, well, so my recollection was that the technical submittal made reference to a particular product,
Yes.
and they sent the product literature with the technical submittal. So therefore I was able to see the product literature, and the product literature declared the test regime that was used, etc. So you were able to determine from the product literature what the standard of the damper was proposed to be.
I see. Did you specifically consider whether the dampers were certified as fire dampers or as smoke control dampers?
I'm not quite sure the context of the question.
Were you aware at the time that dampers are divided into three categories? Fire dampers, fire and smoke dampers, and smoke control dampers, with smoke control dampers being tested to the most onerous performance standards of the three.
Right, it was a smoke control damper because it was being used to control smoke, and it did.
Hang on, sorry.
All right.
Just answer my question. Were you aware that there were three categories of dampers? Fire dampers, fire and smoke dampers, and smoke control dampers?
Yes.
Were you aware of
Yes,
that at the time?
Yes.
And you say it was a smoke control damper because it was used in the smoke control system, but were you aware that to be a smoke control damper, it had to achieve certain testing requirements?
Yes, I was, yeah.
Were you also aware that BS 12101 made clear that if different pressurised or depressurised zones are connected to the same fan or set of fans by a common system of ductwork or shafts, that smoke control dampers needed to be used? Were you aware of that?
Yeah, but we were using the SCA guide on the job, not the... See, the element of the 12101 Part 6 was, in fact, the testing, the 2 minutes with testing regime that was sort of taken for that guide and used as a criteria for the SCA. So I would have been looking in the SCA guide, their criteria for smoke control dampers. And my recollection...
Let's look at the SCA guide. So, for example, in the 2012 guide at LFB 3059241, we go to page 36. If you look at 8.2.5, this is automatic opening vent smoke control damper used for ventilation from corridor or lobby into smoke shaft or smoke controlled duct. It says there no formal product standard exists for the use of these products in this application. But then it goes on, it says to ensure the necessary product performance is achieved, it is recommended that the AOV should be regarded as a smoke control damper and the relevant product standards should be considered. Do you see that?
I do, yeah. We're talking about AOVs here at the moment, though, aren't we?
Yes. So it's got to be a smoke-controlled damper. Can we agree on that?
Yes, smoke control damper, yeah.
Yes. And you're saying that you did in fact check the fire resistance of the dampers by looking at their product information. Is that right?
Yeah. There is a section in the SCA guide that gives a range of different tests appropriate for a smoke control damper, and it followed one of those recommendations.
Well, let's look at the information. Let's look at the information on the dampers. If we go to PSB 50201, this is the literature for the dampers that we have available for the Series 54 Gilbert's dampers. And if we go to the second page of this, you can see, if we blow up the top of that page, second paragraph down, it says, multi-parallel link blade smoke damper. The Series 54 is manufactured from robust 1.5mm galvanized steel and is fully tested to the requirements of EN 1366 Part 2 for 1 hour. Now, did you realise that that's the standard for a natural ventilation system, not for a powered pressure differential system?
You're mentioning pressure differential systems again. I'm using the SCA guide, and I believe this cited standard, the 1366 Part 2, is one of the is an acceptable standard in the SCA guide.
I see. Well,
we can have a look if you like.
In order to be smoke control dampers, there needed to be relevant test evidence to BSEN 1366 Part 10 or classification to BSEN 13501 Part 4.
There are. You carry on, John.
Sorry, and we don't have that. So the EN 1366 Part 2 for 1 hour is not enough to be a smoke control damper. Did you realise that at the time?
The question you're putting me is as though I would have to accept what you say is correct. But I believe the SCA guide cites this as an acceptable standard for the damper. We could go to it if you wish.
Well, do you know where it is in the SCA guide?
Well, not off the top of my head, but it must be near the area where you were just now.
I'm just putting to you that if it's going to be a smoke-controlled damper, which it needed to be, there needed to be relevant test evidence to BSEN 1366 Part 10 and classification to BSEN 13501 Part 4. And the dampers didn't demonstrate that.
You are referring to 2000. See, it is significant about the SCA guide. The 2012 version of the SCA guide had this standard as an acceptable standard. It got changed in the 2015 version, and it's got changed again in the 2020 version.
Like what I read to you earlier when it said it needed to be a smoke control damper, what was recommended, was from the 2012 guide, not the 2015 one.
What they do, in that guide, they go on to tell you what the acceptable standards are. That's just a generic introduction. I'm virtually certain of this.
Okay. Well, I'm sure someone can tell me if there's a particular passage in the SCA guide that I need to take you to. But I think what
happened is that there was a consideration of standards between the 2012 version and the 2015 version, and it's possible that was omitted from the 15 version. That may be worth looking at.
Right.
It's certainly cited in there, definitely. I've got no doubt about it.
Fine. Did you ever consider the fire resistance of the ductwork, either the builder's work shafts going up both north and south, or the level 2 ductwork? Did you ever make an assessment of that and consider its fire resistance?
This was really marked up on the the architect's plans, the shafts were as fire-resisting shafts. So we took that.
So did you just take that at face value? Did you ever actually work out what standard those ducts satisfied when you were approving the system?
Right, so what you have there is existing shafts,
Yes.
made presumably of concrete form, block work, etc. So they, apart from inspection to see if there's any holes in them, that would have been regarded as suitable in the case. I think Beryl Menzies mentions this, that she thought that was an acceptable approach.
I see. So, but did you consider whether the existing builders' work ducts had a minimum of 60 minutes fire resistance for each side separately? Did you ever actually consider that?
Well, it's marked up on the plan, so therefore, the expectation is that's the intention. When they actually look at the system, they would need to do a survey of it and decide if there are any problems with the shaft. There need to be any holes need to be filled up with fire-resisting material, etc., etc. But we take the plan as an intent to make the shaft fire-resisting. It's got a red or green line round it with a note that mentions it's fire-resisting.
Okay. Did you ever consider whether those shafts fell within the definition of protected shafts within the meaning of approved document B, and therefore needed to be treated as protected shafts when the design was being developed?
I mean, you're using a particular definition. A protected shaft is basically a fire-resisting shaft
Yes.
that achieves the same standards as the element of construction in the building. So despite, you mentioned earlier about my reference in B1 and B5, this does kind of cross over actually, because you then have shafts riding up the building. So clearly I did, because I looked at the plans and they showed the shafts as fire resisting, not just the 30 minutes, which would have been just the means of escape standard. So it's
But
kind
did
of
you
a little
realise
crossover.
that would also impose a requirement in terms of the dampers? They would need to be at least fire and smoke dampers to satisfy that requirement of being a protected shaft. Did you ever think about that?
I'd have to challenge what you said there. A protected shaft doesn't require it to have smoke leakage. Do you want me to explain that? It might be helpful if I explain the.
No, what I'm asking you to confirm is whether you ever thought about those builders' ducts and those shafts as protected shafts, and whether you ever thought about what that meant in terms of, for example, the rating of the dampers, the leakage requirements.
The answer is yes. Yes, it is. Yeah. But
Do we see any documentation or notes that you produced setting out what you concluded about that?
Yeah, it's not the normal practice when reviewing a job to, if you look on the plan and you see that the architects marked it up as fire resisting, and then you look at the dampers and they follow the guidance, there is really no need to have a separate note saying, I've looked at the dampers, so we don't do checks maybe to the, what you're assuming. Basically, what we're looking for is something that's wrong, basically. So as these dampers, if they needed smoke resistance, then we'd look at that. If it doesn't, it doesn't. There was a change between the 2000, I don't want to go on, but there was a change between the 2012 version, the 2015 version, and the 2020 version regarding the standard of smoke leakage to dampers. So the 2012 version didn't require smoke leakage to the dampers. The 2015 version did. And we've even got a recommendation on the 2020 version to even enhance that. One of the things to think about is that when an extract system is extracting smoke, because what we're worried about is smoke leaking from one floor to another up the shaft. So if we're extracting smoke and you have a damper on the floor above, you're extracting past the damper. So therefore the smoke's unlikely to leak back in. I don't know if that's a good diagram, but unlikely to leak back in. Because you're extracting. That, I think, was the principle probably on which the 2012 version of the Hestia Guide was based. But we get advancements in the industry about quality and standards. So when smoke dampers are available, which have a degree of leakage, but they still leak smoke, then why not use them? And I think that's resulted in their inclusion in the 2015 version.
Yes, I see. You mentioned earlier that the SCA guide, and you're just referring to it now, had the different standards that would apply for the different types of dampers, fire dampers, smoke control dampers. If we just look at that, go back to the 2012 SCA guide, LFB 3059241, and I want to look at page 37. Can you see at the top there, it tells you which standards are relevant. And you've got 12101 Part 8, smoke and heat exhaustion ventilation smoke control dampers. 1366 Part 10, fire resistance test for service installation smoke control dampers. And then the fire classification using that data for smoke control systems is the EN 13501 Part 4. And then underneath that, in the separate list, we can see that BSEN 1366 Part 2 is the fire resistance test for service installation fire dampers. So that's for the lowest classification or type of damper, 1366 Part 2. And it's 12101 Part 8, 136610 at the top of the page that are relevant to smoke control dampers. That was the point I was putting to you
I see.
earlier.
Yeah. So what you've got here is a number of different standards that can be used, and without question, the bottom one is by comparison a lower standard than the one above, but it is still an acceptable standard.
Well, what I'm suggesting to you is that was the standard for fire dampers, and that numerous pieces of guidance made clear that the dampers for a system like Grenfell Tower needed to be smoke control dampers, tested to more onerous standards as set out at the top of that page. And what I want to ask is, did you notice that at the time? Did you appreciate that? Or did you assume that the 1366 Part 2 was a satisfactory test?
Well, I think it is stating that that is a satisfactory test.
Well, it's saying it's satisfactory for fire dampers, which are the lowest performance level of damper, but it's not the same as a smoke control damper, is it?
It's not as high a standard. What they're doing, they're giving you a list of possible standards that you could use, and right at the end, they're giving you this older standard that was still regarded as suitable at the time.
Yeah.
What happens is you get a lot of development of products, test standards as well, and you've still got a legacy product, a legacy standard that exists. So they're still allowing you to use that standard below. But obviously, if you wanted to go for the modern standard, you'd go for the one above. Generally, what happens is these older standards get written out as time goes on. That's just the way standards work.
One final topic in terms of my pre-prepared questions about the fireman's override switches, so that we know in each lobby there's a little yellow key switch, which was a switch which the fireman could use to override the system and make the smoke control system work in a different lobby from that which it had first activated on. Do you recall that?
No, I didn't know.
Okay. Can we just look at MET 3072161? Can we look? So this is a report that was done for the Metropolitan Police Service by RENA about the smoke control system. And if we can go to page 27 of the report. And I want to look 4 paragraphs down under that section, conclusions. So it said there, it was identified that the fireman's override switches, the FOS, on each floor in the lift lobbies may have been a weak point in the system in the event of a severe fire. The basic construction of these units left them vulnerable to heat damage, dust and water ingress. On the balance of probability, this allowed several of the firefighter override switches devices in the hottest parts of the fire to short circuit, causing the smoke dampers to behave unpredictably. Damage from the fire to the smoke damper actuators would also have prevented them from operating correctly, which led to some smoke control dampers being unable to either open or close in response to the unintended override switch inputs. And then if we can go to the paragraph below, it says, in Rena's opinion, based on product information, the smoke damper actuators and the firefighter override switches were not designed to withstand exposure to the heat from an ongoing fire. As these units were exposed in the lift lobbies, it's likely that the system had not been designed to function reliably in a scenario where significant heat or fire were present in these areas. Now, did you ever give any consideration to whether the construction of the fireman's override switches left them vulnerable to heat damage, dust and water ingress in the event of a fire?
I didn't, and again, it goes back to the value of a BREG engineer.
Yes, and in Dr. Lane's report, she noticed that in PSB's technical submission, the override switches were to be installed on the stairwell on each level, but on the PSB electrical schematic, they were shown in the lobby. So there was an inconsistent location on the PSB documentation about where those override switches were, whether they were in the stairs or the lobbies. Was that something that you ever noticed?
Again, that kind of consideration would have been the BREG engineer, and I explained that the BREG engineer was made redundant, and the process was to accept the commissioning certificate.
So I think it follows that you didn't ever give that any consideration.
You know, it used to be the BREG role to do that kind of thing. So no, I didn't. No.
Thank you. Mr. Chairman, I've come to the end of my pre-prepared questions. I'm sorry that I've taken till
No, that's all right.
9 to do that.
Right.
But
Well,
I've
we
been
need to have the usual break, don't we?
Yes, we do. If we can have a break. I mean, I'm in your hands. I would have thought between 10 and 15 minutes would be adequate.
That's all right, thank you. Well, now, Mr. Hanson, just to explain what's going on now, Council's reached the end of the questions she had prepared. She thinks, therefore, that she's asked all the questions she should have done, but we always have a pause at this point to enable Council to check that there's nothing been overlooked, and to enable others who are following the proceedings but not in the room to suggest questions that perhaps ought to be put to you.
Yeah.
Now, what we would do normally is to have a quarter of an hour break, and then for you to come back and see whether there are any more questions. That will take us later than we would normally sit. Can I ask you, first of all, do you mind sitting a bit later to finish your evidence today?
I don't mind at all.
No, I thought you probably wouldn't. Can I just check shorthand right? Are you all right? All right, thank you. Right, well, in that case, we'll break now and come back at 4:45, all right?
Right.
And then we'll see if there are any more questions for you.
Yeah.
And while you're out of the room, please, again, don't talk to anyone about your evidence or anything relating to it.
I won't.
All right? So if you'd like to give the usher, we'll see you at 4:45.
Thank you.
Well, Ms. Granger, I think 15 minutes ought to be long enough, but if it's thought that more time is required, you can send the usher to tell us.
Thank you. Thank you.
So 4:45 then, please. Right, well, we're ready to resume. I'm going to check that Miss Grange is there and is in contact with us.
Yes, Mr. Chairman, I can hear you clearly.
Oh, good. Hello. Right, then we'll ask Mr. Hanson to come back in, please. Right, Mr. Hanson, sorry we kept you waiting a bit longer than I indicated, but it does happen sometimes.
Okay.
And we'll see if there are any more questions for you. Yes, Miss Grange.
Yes, just 3 short questions, please. Mr. Hanson, we saw in a number of the exchanges that you had with the design team, you were asking consistently for an extract rate of air through the damper in meters cubed. Did you ever actually get that extract rate provided to you?
I didn't know.
No.
Would you like me to explain why I asked for that?
Well, I think you told us that before. I think we understand.
Yeah.
Okay. Okay.
Yeah. Thank you.
Yes, thank you. Second question, did you ever raise the lack of an M&E engineer with your superiors at RBKC? Did you ever explain that was creating difficulties?
Yeah, I did. So what happened was when we'll call it the reshuffle happened, it became clear to me the BREG engineer was being made redundant. So I asked for a meeting with the head of building control, and Billy explained my concerns about this. And, you know, he considered all what I said, but the answer was that we need to make these budgetary cuts, as it were, whatever, you know, the term they use for it. And so I said, well, how then are we going to ensure these systems are suitable? And this is then the description of the process whereby we accept the commissioning, but, you know, we're not going in and checking it. So really, I did, to be quite frank, I did quite robustly not agree with that and made my feelings known, but it seemed to be it was a fait accompli. I've been so concerned about it since, and Grenfell was the first job I ever dealt with without a BREG engineer, and after that job I really felt it was so necessary. So since then I've championed the council to re-employ or provide access at least to make a mechanical and electrical engineer. And I think when I did that, there was 2 management schemes involved. So John Allen was the building control manager, and when I explained it to him, my concerns, he supported my thoughts about it very much so, because he had just taken over as building control manager, and he tried to establish an exchange with other boroughs. So that kind of started.
Yep.
I'm talking about the future now, but anyway, it's a very valuable resource, the BREG engineer, and I think I feel that it's very significant when we're dealing with these mechanical ventilation systems. I would have felt a lot more confident dealing with this job had I had a BREG engineer sitting beside me evaluating the scheme.
Okay, thank you. And just finally, did you ever at the time consider that the LGA guide on purpose-built blocks of flats was relevant to your consideration of the smoke control system?
No.
Okay, thank you. Mr. Chairman, thank you very much. Those are all our questions for Mr. Hanson. It just goes to thank him for attending to assist us today.
Yes, thank you, Ms. Grange. Well, Mr. Hanson, those are all the questions we have for you. It's right that I should thank you very much on behalf of all 3 members of the panel for coming here, spending the day here, giving us your evidence. It's been very interesting and useful to hear what you have to tell us. And I'm sorry it's gone on. We've kept you much later than I thought we might, but at least we finished today. And now you're free to go.
Okay, thank you.
Thank you very much indeed.
Thank you.
Right, would you like to give the usher and then she'll look after you? Thank you very much, Miss Grange. We've got another witness next week on Monday, is that right?
Yes, we have the designer of the system on Monday, Mr. Mahoney.
And again, you're going to take him.
I will be taking him, yes.
And we shall have the same arrangements for those who are interested to know as we have today.
Yes, we will. And then hopefully I'll be back with you in person on Tuesday.
Good. We'll look forward to that. All right. Thank you very much. Well, at that point, we'll conclude for the day and we shall resume at 10 o'clock on Monday morning next week. Thank you all very much.